continue to help the Water Authority design and install renewable energy systems. But before we can really go to the future, we need to sometimes step back a little bit to the past. And in 1950, our forefathers imported wood from Guyana. And they would use this wood as a fuel, and through the mechanics of converting water to steam through these steam engines that are still there, relics at the Bell pumping station, our forefathers would burn wood and fuel to produce steam, and these steam engines will, steam pumps would deliver water to the residents of the Barbados back in the 1950s. You know, when the economic situation disintegrated in Guyana in the 1950s, what happened is that they switched from wood to fuel oil and heavy fuel. And they would actually use this fuel in the boilers to produce steam again, and through the mechanics of what you see here, a representation of what we did. And it's interesting to know that these forefathers used primarily wood, which was a renewable energy product, to generate electricity or generate energy in order to pump water. And somehow, someone got smart with the introduction of electrical pumps and decided to buy electricity from the Barbados Light and Power. So somehow we were rudely, at the Barbados Water Authority, rudely interrupted, and we are now purchasing electricity from the Barbados Light and Power to power our pumps. You ask the question why renewable energy is not something new, because our forefather engineers were actually doing this in the 1950s. I mean, what is a renewable energy product? Water and steam. But today now, we have been interrupted, and we are now purchasing electricity at a very high cost to power our pumps and to deliver water to our customers within this country at a very high cost to us. But before we enter into renewable energy, one of the things that you need to understand is this terminology here: levelized cost of electricity. To really appreciate renewable energy and its impact, you have to first look at the levelized cost of electricity, which is known as LEC, levelized electrical cost, right? And it is really the price at which electricity must be generated from a specific source to break even over the lifetime of a project. It is an economic assessment of the cost of the energy generating system, including all the costs over its lifetime: initial investment, the cost of capital, operations, and is a very useful term if you are involved in energy management in calculating the cost of generation from different sources. So don't worry about the equation, you're not at school. This is the equations that we would use in order to compare energy costs of photovoltaics, wind turbine against coal, against natural gas. So you want to have a standard. LOCE, or levelized cost of electricity, this type of calculation assists policymakers, researchers, and others to guide any discussions and the decision-making process. So engineers in the past didn't have levelized cost of electricity, but today we understand that this is what they were using in order to use steam and fuel. But today we have the ability to do it. So as you can see, this is the complicated equation that is used in terms of the management process. But in the past, our forefather engineers, they were operating at a levelized cost of electricity. Somewhere around, if you look at the diagram, they were producing energy to pump water to its citizens at a cost of about 15 cents to about 12 cents a kilowatt. Today we are paying 6 times the amount, 75 cents a kilowatt for electricity in order to distribute water to our residents, right? So we can use and see that this is what our forefathers were doing, our engineering forefathers. And you ask yourself, why today is the Barbados Water Authority buying electricity from BLMP when we could have done it ourselves and just change the technology as such? Today we are paying a high price. So my goal is to help the Barbados Water Authority achieve this here again, levelized cost of electricity. Why so? Why renewable energy? The Barbados Water Authority is facing an economic challenge of meeting its energy consumption bill. Our monthly costs range, ladies and gentlemen, between $2.5 to $3 million a month, $36 million a year for purchase of electricity in order to pump water to our citizens. And I bet some of you didn't know that. $18 million a year is no small feat, and it is a challenge. The bulk of the energy is used to power pumps, motors, for supplying potable water and the process of wastewater treatment facilities. Ladies and gentlemen, we account at the Barbados Water Authority for 5% of the energy demand that is found at Barbados Light and Power, 5%. It is said that when it is that we pay the Barbados Light and Power, it covers their wage bill. So you can imagine what the rest goes towards, probably profit as such. So a couple of months ago, well, I don't want to mention that particular one, but you could just imagine, ladies and gentlemen, that the type of economic constraints that we are facing in this scenario. So you ask yourself, really, what is being done? Well, in light of the Sustainable Energy Framework of Barbados government, the BWA has embarked on an energy efficient and a renewable energy strategic plan. And under the guidance of Mr. Lawrence Cumberbatch, who is at the IDB team, and Ms. Kate Best, our chairperson, they have been involved in training, sensitizing, and the procurement of energy efficient motors. And just a little bit about that, one of our engineers, he's right here, Mr. Wayne Richards, a couple of years ago, he introduced VFDs, variable frequency drives. And it was a bit frowned upon because it was a new technology. Now today, based on the strategic implementation of VFDs, Mr. Richards has shown that these variable frequency drives, which we'll talk a little bit more, can save the Barbados Water Authority more than 10% of the value that we pay to the Barbados Light and Power. Renewable energy products, more specifically the use of photovoltaic products at some of its portable water pumping sites. We are looking at it, and at both of the wastewater treatment facility. If some of you know the wastewater treatment plant here in Lake Folly, the building has the capacity to carry a 150 kilowatt system, which the IDB has been looking to procure and design. You ask yourself, is the technology for wastewater? Yes. The answer is yes. The technology is basically relatively simple. Simple if you have trained personnel. And if your current electrical switch gear is relatively up to date, which is not the case of the Barbados Water Authority, well then there's no major overhaul for the components to interconnect the renewable energy. And it's quite simple once you have the trained personnel. What systems are we looking at? We are looking obviously at the grid-tie systems. We cannot operate without Barbados Light and Power because most of the bulk of the energy, the amps, really comes from them. But what we are looking at is installing commercial grade transformerless inverters, which are readily available. They are available. They've been using in the States for a number of years, in England and Germany. And I found personally that it is easier to install renewable energy systems within a commercial sector as opposed to residential. You would know, personally speaking, that Barbados is one of the 5 countries in the world that has a very complicated grid. We operate both on the English system and both on the American system. So we have 50 Hertz, which is English, and also split phase, which is the American. So it is difficult to really sometimes get inverters, but at the commercial level, the inverters are readily accessible. We have the 200 volt inverters, 277 volts, 400 volts at 50 Hertz split phase, making commercial photovoltaic applications a lot simpler, where you can just go in and buy these particular inverters. What you can see, ladies and gentlemen, if you are familiar, this is just a basic system of a grid tie, what we are looking to interconnect. So it is just made up of a number of solar systems. It's going to be a lot more for industrial application. There's a combiner boxes which really strings the panels together to increase voltage and amps according to the size of the inverter. You have DC disconnects, which is the normal things that you have at an inverter. At any point where you have an interconnection point to the grid, you can interconnect a solar photovoltaic system. So this is not rocket science. With trained personnel, a person can install one of these systems at the Barbados Water Authority. And what I've found is that we have a complement of staff that are capable, electricians, mechanics that are capable of helping us do these particular projects. In fact, this is just another diagram of what a renewable system can connect. Please don't be confused or look at the complication of the amount of wires or the systems they're drawing. For persons who are involved in electricity and photovoltaic, this is very, very, very simple. You simply just go from the PV array to an inverter, as from SMA, which is one of the leading brands on the German inverters, which I use, and also Solar Edge. There are interconnects, there's breakers, and from there it goes through what before a production meter, and then you have a bidirectional meter. So what it does is that you have a net metering. This is a net metering effect. But at Barbados Water Authority, I can tell you, we will never produce enough electricity to sell back to the grid based on what we use. So it is a matter of just supplementing what we use from the Barbados Light and Power. What you see here is a basic component system for a 150 kilowatt system. You would basically have 3 inverters, and you're going to see a lot more of these SMA inverters. They're used a lot in Barbados. They're the leading German brand. And the 3-phase system is really just 350 kilowatt inverters, about 580 to 600 photovoltaic modules, greater than 255 watts. Those are some that I use. They are greater. They are those that are about 350 watts. You have 2,050 feet of solar mount arrays, and the balance of the system is about 20% of the total cost. And if you're looking at 500 kilowatt to 1 megawatt project, this is what it will look like. And this is what I'm hoping that based on the funding that we have right now that is available, that we can install some of these systems. This is what is done in the wider world of 500 kilowatt system. And ladies and gentlemen, we have the capacity, the engineering at Barbados Water Authority to implement these type of systems right here based on what we feel we have. And if you don't want to go to the micro inverters or the smaller inverters, there are also megawatt inverters. And this company I've been talking to over the past, this is Solar Electrica, and they have smart grid inverters on a megawatt level. And these are some of these things that we can implement. These are pad mounted, they can be easily shipped, converted, and we have a smart metering. I know Mr. Richards there is talking about solar farm at the Bell, and these are some of the inverters that we are looking to procure in order for our designs. So what are the goals of Barbados Water Authority? The goals that we have today is to move the 71 cents a kilowatt that we pay today for electricity to less than 30% tomorrow, and even a lot less than that. Improve the energy efficiency of operations with the implementation of energy efficient technologies. And right now, the team IDB, headed by Mr. Lawrence Kalmabash and Ms. Kim Best and those others, are strategically working towards this. They have now looked at the procurement of about 110 VFDs, and with the implementation of these VFDs, we are going to lower our energy costs by at least 10 to 15% with this. And what I mentioned, having spoken to these individuals, is that energy efficiency complements renewable energy. You don't do one without the other, and the payback is a lot better. And install high viable renewable energy commercial grid type systems. What is the current progress again? Well, the current progress is that the successful installation of variable frequency drives. And if you're not familiar, what these drives do, they are the ultimate solve start. And I know Mr. Richards, he was the one who was pioneering this, and it has now taken form at the Barbados Water Authority under the IDB program. These drives, what they do, they allow the pump to operate at varying speeds. So when the load is not very high, it can actually throttle down the particular the motors. For example, this is some data taken about the before and after the installation of a VFD, along with what we are doing at the Barbados Water Authority, Mr. Kalmabash and those others. Currently, if you have a motor that's using 607 kilowatts per day, the annual use is 221,000 kilowatt hours, and the value that we pay for that, for a particular motor right now, we have more than 100 motors at Barbados Water Authority. It's about $26,570 for one motor to pump water to the citizens of Barbados. With the installation of a VFD, which costs about $3,000 to $5,000, this VFD can actually regulate the energy input and throttle it down and save energy to the form of 482 kilowatt hours per day, which is a saving of 176,000 kilowatt hours per year. That tantamount to energy usage of $21,000 per year. The savings, you save the electricity, you save the environment 125 kilowatt hours, 45,000 kilowatt hours per year, and that savings tantamount to $5,450 US. A VFD drive costs maximum about $5,000 or so, right, Mr. Richards?
Yeah, very fine.
Very on the site. But what I like about it is that the payback period for a VFD is less than a year. It's less than a year. So we can see where we are going in terms of helping the Water Authority under the IDB and various engineers. Current progress, the installation of VFDs through Barbados Water Authority portable and wastewater sites. And I know Ms. Kim Best and Mr. Cumberbatch is working on that. And what also that I have proposed that is waiting approval is that I have proposed a pilot project to install 20 kilowatt PV system at the Golden Ridge Reservoir. And I know that Mr. Richards and Mr. Marvel will be quite happy about this. And what this will do for the company is show individuals within our country that we at the Barbados Water Authority are capable of implementing these projects ourselves. There's no need to bring in external forces or external persons to do this for us. We have a complement of young engineers capable of doing this along with allowing me to train these ones. And this will build capacity training and capacity building for the technical staff at the Barbados Water Authority. Renewable energy is not just engineering. It is accounting, it is human resource, it is all faculties. And I'm hoping with after getting approval for this 20 kilowatt system, is that we're going to do a training session. And the best way to learn about PV is to actually install one yourself. And this is what I'm waiting on. So currently it is now at board approval. I have also designed and financially the costing system.